Today I discuss about differential calculus. Start from limit. What is limit? What is continuity? So for this we have to take a function on any variable x. So take a function y is equal to fx. Now, so here if we take a Cartesian coordinate x-axis and y-axis, their origin at O, and this person represented by this curve y equal to fx. Then for any point x, x0, we have a point on the curve here. This is fx or y0 or x fx. So limit point means we have to take, and we wish to know what will be the limit point at the point x, and the difference at difference in fx. So limit of we have to take x is equal to alpha. We have to find out the limiting value. I'm taking x is equal to alpha. X is equal to alpha. And at this point alpha, what will be the limit point at fx, what at y. So if x tends to alpha, if x nearly to alpha, not equal to alpha, then what will be the value of fx, and limiting value of fx. So we can take this from right hand side also, and from left hand side, or this also. If we take from the right hand side, or take left hand side, then the limiting value will touch the fx at f alpha or not. For x is equal to alpha, we know that this value will be fx will be then f alpha. So if we take limiting values of x is equal to alpha from right hand side, this is denoted by x tends to plus alpha, and this will be we will take alpha, just a short diagram I am taking. Alpha values not equal to alpha, then it will be alpha point alpha value in this way, alpha point 001, alpha point 002. I am not given any equation, so you cannot understand this way. I am taking y equal to x plus 1, then if x is equal to 0.001, then y is equal to 1.01. If x is equal to 0.002, y will be 1.002. In this way, if we take x equal to 0.1, then y will be 1.1. So we can take many values in such a way. If we put these, then we will get the value at the point x equal to 1. For x equal to 1, this point becomes x equal to 1. This value actually becomes, we will take x equal to 0. For x equal to 0, the point becomes y equal to becomes 1. So we have to verify here that for the point x equal to 0, what will be the value of y. So these all points taken from the right hand side, all are positive, means at this point 0, all the points are coming at 0 point of x, and from right hand side, if we take alternatively y x equal to 0.99, then y will be 1.99. We take x equal to 0.95, then y will be 1.95. If we take x equal to 0.9, then y will be 1.9. In this way, if from the left hand side we will also take, so we can look this on the left hand side. It also y is this point we are taking negatively actually. When we will take left hand side actually, then it will be all minus actually, not plus. So here x will be minus actually. These are right hand side, and this is all left hand side. Here x is equal to negative actually. So this will be, this value will be changed. This will be 0.01. This will be 0.05. This will be 0.1. So here also we can look this as we approach from the left hand side to the point 0. Now y will again touches the origin O, means x is equal to 0. So here for the point 1, for the point 0, x equal to fx. For this example actually, y equal to fx, x plus 1 for this equation. So if x tends to 0, from right hand side we will be getting the fx value is 1. All are y's value we can look is nearly 1, means this value is 1, 0. And from the left hand side, if we take limit fx, x tends to 0 minus, then also we are looking at after it oppositely, here it will be minus x. This is minus x, this is y. So all values are here negative. These values nearly to 0. These all values are getting nearly 0, and these all values are nearly 1. So limit of fx when x tends to 0 minus, it will be all nearly 1. And if we take x is equal to 1, then y is equal to, we will get x equal to 0, then we will get y equal to 1. So here limit of x, limit of fx, x tends to 0 plus equal to limit of fx, x tends to 0 minus equal to f0. So if this condition holds, then we will say that fx is continuous at the point 0. Fx is continuous means left hand limit. This is for left hand limit. This is for right hand limit. All are equal. Both these are equal. And we will say that fx is continuous and exists. Fx exists and continuous at this point. Here this point is 0. We can take a random point alpha also, and if this condition satisfied, then we will say that fx is fx limit value at the point any random point alpha is exists and continuous at that point the limit exists and continuous at x is equal to any random point alpha. So this is the basic assumption of limit and its continuity. If we go in differentiation, then what will be for differentiation? We have to know the definition of the first derivative. Here also we know that what is the condition of continuity for differentiation. Condition of continuity for differentiation.